All right, so what we're going to do is just look at a microscope, look at the parts of the microscope because it's something you're going to have to identify in the laboratory. And then just go over the really basic getting started with the microscope and focusing. Okay, so we're going to do parts and focusing really quick, just as an overview. So when you get your microscope, and I have another microscope here, similar to the one that you'll probably be using in lab. And we'll look at the parts of it first so you can communicate with other people and tell them if you have a problem with a specific part or that you just actually know how the parts work. So first part up here, one of the parts that you're going to interact with are going to be the eyepieces, also known as the oculars. And that in that way, certain microscopes only have one ocular, they're monocular, or they are binocular. So this particular microscope is a binocular microscope. It has two oculars. Each of these oculars has on its own, and this is typical, a 10x magnification. So it's going to magnify what you're seeing 10 times right there. There's a little lens in there to do that. Now what's going to happen is, without knowing exactly what's going on in here, there's going to be, come down to the bottom, with the way the microscope works. You're going to have a light source down here. Usually somewhere on the microscope, maybe here or over here, you're going to have the light controller. All right, so you're going to control the light. And this varies by the microscope. This particular microscope I have, like this one here, has a little dial on the base. But other ones I use in a different lab have a little knob up on the side on the arm. Okay, so add these in here too. This is the base. And then this is the arm. As you can see, it's important to know these things because if someone says, oh, look for that on the base, and you don't know what they're talking about, then it's not very helpful. So the light itself is going to come from this light source up to another series of lenses here that are typically not magnifying. It's a structure called the condenser, which you'll usually see underneath the stage. So this part here, this flat part here at the top, that's the stage. So the stage is usually where you place your slide. So the slide would go in here, and this would be the slide. This over here is going to be, draw it over this way, your slide holder. And it's usually a mechanical slide holder, which means in addition to a little clip, which you can see here, there's a little clip that moves back and forth. The slide would fit in here, and then this little arm is typically spring-loaded. There's a little spring here, and it can move and actually kind of hold the slide at a 90-degree angle in the corner there. So when you put your slide on the stage, you should push it into this mechanical holder, pull back the little spring, let it kind of grab your slide and hold it in place. Then there's going to be some knobs on the side of the stage, typically sticking off it over here, like this. And these are going to be, they have a number of different names. Generically, we'll just call them slide movers. And they'll move the slide back and forth. And the idea is you want your slide to line up directly with the light that's coming from the stage to the bottom. So when you first get a slide, you put it on the stage, put it in place with your slide clips, you have your light turned on, and then you can actually see, is the light hitting the slide or not? And then you would use the slide movers to move that slide to the right location. Sometimes these are called XY axis adjustment or rack and pinion. Those are other names for it, but slide mover typically works. So now what's going to happen? Light is coming up through the base, goes through your condenser, which I didn't get to what it actually does. The condenser is the place where the light can be modified and there could be filters added into it. One of the things that we work with commonly in the lab that's part of the condenser, there's a little knob here that's connected to something called the iris diaphragm. And many times in lab, this is going to be one of, besides focusing, one of the more important things that you can adjust on the microscope, because the iris diaphragm, see on this particular microscope here, this is the condenser underneath the stage. There's a little lever here, and that little lever is adjusting the iris diaphragm. What it's doing is it's essentially opening and closing, and it's not changing the intensity of the light, that's the light control, but it's adjusting like how much light is getting through here, which can then hit a series of filters and other lenses that focuses the light on the slide itself. Now, different types of microscopes can have different sorts of filters and lenses put into the condenser. So this is a light field microscope. When typically you use a microscope, the background is bright, it's light, and then the things you see on the slide are usually darker. With adjusting that filter, with adjusting parts of the condenser, you can have something called a dark field microscope, where the background is actually dark and what you see on the slide is actually lit up because of the way the light is bent. There's phase contrast microscopy, which again puts other sort of filters in there and alters the path of the light, focusing it and pulling it back together again to change qualities of things that then you would see. So that's beyond what we really need right now, but there's a lot going on with the condenser, or there's a lot that can go on. But what I would like you to know is that this is the condenser, and then the part we're going to use is the iris diaphragm. It's going to help increase contrast. That's kind of the main thing to also get out of this is, what is the iris diaphragm? Why would you want to use it? Increase contrast, so light and dark. And it's especially helpful for things that aren't particularly stained very well. You can then really see their outline and detailed structures using adjusting the iris diaphragm. If it's all the way open, sometimes you look at your slide and it appears that there's nothing there, and then you adjust it and also like pop all these things that appear on the slide. So it's very useful. You put your slide on the stage, clip it in, you have the light turned on, you move it so that it's in the light path. Then you're going to have your objectives. Now, this microscope here that I have, and most of the microscopes that you'll use, will usually have 4 objectives. There's going to be typically a 4x, a 10x, a 40x, and a 100x objective. You're always going to start with the 4x objective. And in addition, when storing a microscope and putting it away and bringing it back out again, it should be like this microscope here. The smallest, the shortest of those objectives is the 4x. And that's the one that should always be in place when you put the microscope away back into a cabinet. If another lens is in place, you're putting it away wrong, and it's dangerous, you can damage the microscope. So make sure you put the smallest lens in place. In addition, now when you're focusing, this is going to have the widest field of view, so you're going to be able to see a lot more of the slide itself and find the things that you're looking for, where you can keep then adjusting the slide movers and narrow down to a very particular structure that you're trying to focus on or find. So you put the 4x in place. So the 4x objective is where you always start. Always. You never start with anything else. If you start with anything else, you're really just going to be wasting your time, because it's much harder to focus under the higher magnifications, and there's a much narrower field of view, so it's more likely you're going to miss what you're looking for and have to use the slide movers a lot more. You might be going in the opposite direction that you're actually looking for, so get the biggest field of view and the easiest one to focus. Now, when you're focusing, best thing to do right now is you have your slide on here. The stage is as low as it can possibly be. That's the safe way to store it. But once you would have the lights turned on, I can plug this in right now, but you would now then look through the eyepieces or the oculars, and then you would start raising the stage up. Now, typically it's going to be blurry, so what you can do is also, to be safe, is not look through them yet, and actually just raise the stage all the way up as high as it can possibly go, and make sure that it's not banging into any of the objectives. Now, when you go ahead and look through the eyepieces, you should see something on your slide. If you did these steps properly, you should actually see a structure, dark, light, colorful, whatever it is that you're looking at. And at that point, you'll then move on to the focus knobs. You have 2 focus knobs here. A larger one, that's the coarse. And then a smaller one, that's the fine focus. And depending on how blurry the thing is that you're looking at, you may just want to grab the smaller fine focus knob and just be looking through here until and you kind of rotate this away from you, then kind of back toward you to kind of see better, worse, just like if you're at an optometrist, and then turn it in that direction till it looks really nice and sharp, and then you stop. And that's your image, and then you focus. Now what's going on here is then the light has gone from the light source, through the condenser, through your slide, it's gone up into the objective, which has now magnified it, in this case 4 times. It then hits typically a mirror in here, and then it kind of bounces around, and then it adjusts it up through the eyepiece, the ocular, which also magnifies it 10 more times. So technically, when you have the 4x objective in place, you're seeing something magnified. Running out of room there. Magnification is actually 40x. So it's 40x magnification with the 4 objective. So again, here at the 40 objective, that would actually be 400x, and at the 100x objective, that's actually 1,000. And obviously here is 100. Now, when you're using the microscope, typically, most people are only going to use these first 3 objectives. In a microbiology course, or where you're looking at really fine cellular structure, you'll use the 100x objective to get a total magnification of 1,000. Now the thing is, the 100x objective is a special kind of objective that's an oil immersion objective, and that's something a little bit beyond what I'm just talking about now. So typically you won't be using it, you shouldn't be using it unless you're specifically trained to use it properly. Otherwise, it's highly likely you're going to damage the microscope. What typically happens is people do not remove the slide properly, and then they get the 40x touching oil that's on the slide, and it is not sealed. The oil gets in and ruins it. So people then, when they get a microscope, you can see at the 4x, the 10x, and you go to 40, and you see absolutely nothing. It's just a total blur. There's no way to focus it, and no one can help you because it's been damaged in a way that needs a professional person to repair. That is going to be a couple other little side things. Besides a couple side things, the majority of the things you would need to know. So, eyepieces, objectives, your stage, your mechanical stage clip, your slide movers that are on the stage, your condenser with iris diaphragm, the light source, the adjuster that's going to control the light, the focus knobs, the coarse and fine focus. You would grab and hold the microscope, typically by the arm and the base. This area though here, I mentioned that the objectives, that they're multiple objectives. Typically it's like there's a ring here. I'm going to kind of zoom it all around this way. Okay, so this ring here is called a rotating nose piece. And usually what would happen is, once you focus at the 4x objective, when you start, you get it in focus and you say, that's really nice, I see it, but I need it bigger. So then what you would do is safely, you can actually see here, rotate, make sure I'm going the right direction, rotate the objective to the 10x. So you would go from 4 to 10. Then you would come back to your microscope, use the fine focus, get it nice and clear. You might use the stage movers here, slide movers to actually, technically that's what happens. One of them moves the slide, the clip. The other actually moves the stage. So one will move the stage, you can probably see this here, one will move the stage back and forth, and the other will move the slide left and right. Okay, so it'll adjust it. Focus in on exactly what you want, like if crosshairs are put on it, because what's going to happen next is you go to the next higher power, your field of view is going to get smaller, and if you're not centered exactly on the thing you want to see, it's going to vanish. You'll say, well, where is it? It's gone. And then you're going to have to search for it, and that wastes a lot of time, and it's difficult. So you focus in there. If you need to go up higher power, once it's focused, you then rotate it one more time, to the 40x objective, and that's it. Now, when you're done, you make a drawing, or you're commenting, you're showing it to somebody else, then you rotate it all the way back to the 4x, the smallest, first before you do anything. Then you put the stage down, okay? It's important to put the 4x in place first, because if you accidentally turn this the wrong way and raise the stage up, it could hit the 40x objective. So you put the stage down all the way, and I get the smallest objective in place, 4x, the stage is down, you remove your slide, so you have a lot of room to work there. If you have to clean anything up, you would clean it up and then put things away. All right, so make sure you know these parts of the microscope and some of these basics about getting started with